I'm Anil Kumar, and in this video I'm going to discuss how to find polynomial equation from a transformed graph. Question is, describe the transformations that were applied to y equals to x cubed to produce the following graph. So we have a graph here which has been transformed. We are given 2 points. One is minus 4, minus 2. The other one is minus 3, minus 5. You can pause the video, write down the equation of the transform function and describe the transformations. Now to describe the transformations, let's begin by sketching graph of original function so that we understand what the original function would have been like. So original function y equals to x cubed will have a point at the origin, right? It will go through origin, and then 1 cube is 1, so that will be plus 1, and then at minus 1 cube is minus 1, so that will be the next point. Also, if x is a very large positive value, then y will be very large positive value. That means the end behavior is kind of like this. When x is very large negative value, y will be very large negative values coming down somewhere, right? So basically you'll find that the graph is like this. Now if you compare the given graph with this graph of x cubed, you will notice that this point, which was at origin, has moved 4 units left and 2 units down. So we can describe translation from here. So we could write here that there is a horizontal translation of 4 units to the left, and 2 units down gives us vertical translation of 2 units down. So that means that the origin, the point which went through origin, has been translated 4 units left and 2 units down, right? So that is the translation. And now let's look into vertical stretch and horizontal stretch or compressions. So we'll assume that there is no horizontal stretch or compression. That will make our job simpler. Now we'll consider vertical stretch or compression. If we move 1 unit to right, then in this particular case, moving 1 unit to right means 1 unit up. So that is the point which is 1, 1. Now what happens to this point here? If you move 1 unit to the right, then it actually moves. The point is at minus 5. 3 units down, do you see? From minus 2 to minus 5, it moves 3 units down. 1, 2, and 3, minus 5. So that means there is one, it goes into the reverse direction. So there is a vertical reflection, correct? And the other thing is that there is a stretch by a factor of 3. Instead of 1, it is 3 units, right? So there are these 2 transformations. 1, I'm writing all in reverse orders. 1, what we see is that there is a reflection on x-axis. And the other thing which we notice is there is vertical stretch. By a factor of 3, correct? So these are the transformations which have taken place to our parent function y equals to x cubed. To our parent function y equals to x cubed to give the given graph. Now we can write down the equation of this function. From these transformation, we can say that the function f of x is equal to, reflection means negative, vertical stretch by 3 means times 3 for the function x cube, where x cube has been translated horizontally 4 units left means x plus 4, that's the function, right? And 2 units down means minus 2. So that becomes the transformed function.